Okay, so in 10.6, when we're dealing with these segment relationships, you've read that top part on page 306 there, the tangent segment. Tangent segment is just a piece of a tangent. Now, a tangent goes on forever, so when we say the segment of it, we're talking about just from P to S. Because technically this tangent, they don't show it, but it keeps extending, right? It like doesn't stop. So a segment of it is just the chunk that goes from its starting point to where it hits the circle. Okay. A secant segment is the piece that starts at our point and goes through the circle to the second point on the circle. Okay? You have, within that secant segment, you have what's called an external segment, the part that lies outside the circle. What would we call this part then? Yeah, that's our internal segment. Okay? All right. So, when you're dealing with that, you can come up with, you have two different formulas that we hit on. We know that the relationship between EA and the entire length, so the external segment times the whole segment, is equal to this part times that whole segment. So EA times EB is equal to EC times ED. Okay. Now if we were to kind of extend this segment, kind of lift it upwards a bit until it hits there and it becomes a tangent segment. Well, now we take the tangent segment times itself. Okay, so we say EA to the second power, so EA times EA is equal to EC times ED. All right, and those kind of relate to what's on that previous page there, where you have your segments of chord theorem, where you say that EA times ED is equal to DE times CE. Those are our three new formulas. All right, I want you to take a look at that. Let's apply those on page 307. Take a look at those and apply them on page 307. Go ahead and complete problems 1 through 4 with your groupies. Write out your formulas each time, otherwise it's going to be very difficult for you. Okay, how many have started number 1? How many have got to the point where you have to do some factoring? No? So we do x, so this length times that length, x times x plus 1 is equal to 6 times 5. Everyone made it that far? Okay. This is x squared and x. And that's 30. 30. And then to solve a quadratic, you can either use the quadratic formula or completing the square or graphing or factoring. Question is, are there two things that multiply to make negative 30 and add to 1? Yeah. Negative 5 and positive 6. Okay. Negative 5 times 6 is negative 30, and 6 plus negative 5, or 6 minus 5, is 1. So you find that x equals, so this is x plus 6 equals 0, because if this times this equals 0, then one of those two things has to be 0. So what does x become here? X equals negative 6, and what's x become here? 5. Which one of those can be a length? Cynthia? X equals 5. Why can't negative 6 be a length? Can't have a negative length. If you want to see if you did it right, plug it back in. We know this is 30. Is 5 times 6 30? Yep, it is. We're good to go. X equals 5. Now, you had to factor that one. You don't have to factor them all. You 10 times 7x and 15 times 5x minus 2. Do we have to factor this one? Nope. It's 70x. That's 75x minus 30. Subtract our 75 over, we get negative 5x is equal to negative 30. So x is 6. And once again, you can check it. Should work out. Okay, any questions on those two? Pictures kind of change up now. It's still number 3, but okay. Go ahead and write out your formula there for number 3. This one's a little tougher. So external times entire. So don't mess up here. The external is x plus 2. What's the entire length? Yeah, it's x plus 2 plus 1, which is x plus 3. So that plus that is x plus 3. Right? So you get this outer part times the whole thing. So combining the two, you get x plus 3. And that's equal to the external, 2, times the entire thing. Well, the entire thing is 2 plus x plus 3. Well, 2 plus x plus 3 is x plus 5. You've got to combine those two. 2 times x plus 5. So that equals that. All right, do we get a quadratic on this one? Yeah. What do you got, Carl?
I was going to ask, why are you combining them when it just says to multiply the internal by the external?
You multiply the external by the whole thing. So this becomes 2x plus 10. Remember how to multiply these out. X squared plus 3x plus 2x plus 6. Next year, I'd hope that you could just look at that and go, yeah, I know that's x squared plus 5x plus 6. Okay? Move that 2x over. You get x squared plus 3x. Move that 10 over. Subtract 10, you get negative 4 equals 0. Then we have to factor 2 things that multiply to make negative 4 and add to 3. Huh? 2 things that multiply. No, it's multiply to get negative 4. Add to 3. Yeah. 4 negative 1? Good. All right. We take it in. Here you get x equals negative 4. Here you get x equals 1. Can x equal negative 4? Make sure, if I plug negative 4 in here, will I get a positive length? No, I get negative 1. However, what if x is negative 1? Would it have worked right here? Yeah, so make sure you double check that. It's got to work in both spots. But in this case, negative 4 doesn't work. X equals 1. Isaac, question? No, you're multiplying this length by the entire length. So you're multiplying external by the entire. Yeah, Cynthia?
If ever both possibilities of x end up being accurate, or like they could be accurate, would you have to put down both answers?
You would. But that's, yeah, you probably, yeah. That wouldn't make much sense on it. But you could. It could happen. It's not going to, I don't know. I haven't seen it yet and what we're going through. So. All right. Number 4. This is x plus 1 quantity squared. And this one is x minus 1 times that whole thing, which is, when we combine those, you get x minus 1 plus 5, or x plus 4. X plus 1 squared is not just x squared plus 1. It is x plus 1 times x plus 1. X plus 1 times x plus 1 is x squared plus 2x plus 1. That's where you do your FOIL, or distributive property there. This one is x squared plus 3x minus 4. Good thinking. Yeah, here you're liking it. Subtract x squared from both sides. When I do that, it's gone there and it's gone there. That's nice. All right. If I subtract this x squared over here, it's going to make it equal 0. Okay, move my x's over to one side, my constants over to the other. So if I subtract 2x here, and then add 4, that's gone. This is 5, and here we get x. X equals 5. Falls out really nice.